Good evening, everyone. So this is your Task 6 class. Okay. So basically, your Task 6 class is of the time series analysis. Okay. So basically, in this, we'll see two projects. First is time series analysis. You have to forecast sales over time using ARIMA model. And second is heart disease prediction. You have to predict heart disease using logistic regression. Okay. So first, we'll start with your time series. Okay, so first we'll see all the concept used in your time series analysis, which is your forecasting sales with ARIMA, and then we'll see the second project. Okay, so first concept we'll use is time series. So basically data points indexed in time series, time order, example daily sales. Okay, then you have to do the trend analysis. You have to understand pattern over time. Okay, increasing, decreasing, seasonal. Okay, then is ARIMA. So what is ARIMA? Basically, its full form first is auto-regressive integrated moving average. Okay. So AR means auto-regression, which uses past values to predict future values. I is integrated differencing step to make data stationary. MA is moving average, which uses past forecast errors to improve predictions. So these are the basic concept we'll use: time series, trend analysis, and ARIMA. So basically your step 1 will be your import libraries, necessary libraries you have to import. Then will be your load and explore the dataset. This we already did, cleaning dataset, etc. This the major steps you have to perform every time. Okay. Then comes you have to visualize sales trends. Okay. So basically you have to plot a line plot. So here you have to line plot helps visualize long term sales trends. Okay. So we have to use dot you have to use dot plot function here, and sales column you have to call here, and label will be your sales data and color will be your blue. Okay, rest all other indexes will be same. Then you have to check stationary. Okay, which is also known as Dickey Fuller test. Okay, so in this you have to use ADF test. Okay, this ADF Fuller. So this check if data is stationary or not. Okay, and here you have to check p value. If p value is greater than 0.05, the data is non-stationary and we need differential here. Okay, now step 6 is you have to build ARIMA model. So for ARIMA model here, order is your PDQ. Okay, this is the model here fixed as PDQ, which define ARIMA parameters. So here P is the number of lag observation in auto regression, D is stationary, and Q is your moving average component. Okay, so now comes your step 7, which is your visualize forecast. Okay, we have to do the forecasting visualization, which help understand future sales trends. Okay, so this is how you have to do your first project. Now we'll see the second, which is your heart disease prediction logistic regression. So first I'll tell you what is the concept we'll use. First is classification. We'll predict if a patient has heart disease or not. Then the feature engineering we'll use, which is the first scaling with standardized numerical data, and second is encoding, which convert categorical variables to numerical. Okay, and then is logistic regression will use, which used for binary classification. Okay, and third is evaluation metrics. So there are 4 types of evaluation metric. First is confusion metric, which measure true positive, false negative, and accuracy, precision, recall, reference score. This also will take into the consider to evaluate our metrics. Okay, so first in this also you have to import basic libraries. You have to load and explore data. Then here you have to pre-process data. Step 3 is pre-process data. You have to use standardization, which ensure that all numerical features have a mean of 0 and the standard deviation of 1. Okay, and then you have to do train test with, which means 80% of training and 20% will be your test part. Then you have to step 4 is you have to train logistic linear regression model. So logistic regression is used for binary classification. Okay, then the accuracy score you have to mention, which measures the proportion of correctly predicted cases. Okay, then step 5 will be your evaluate model performance. So for evaluating model performance, we'll see the confusion metrics will show true positive, false negative, and true negative, and then we'll make a classification report. Will include precision, recall, and FN score. Then we'll plot confusion metrics of your project. Okay, so this is how you have to do your second project also. So I hope it's clear. First you have to do this, okay, and second of time series analysis, and second you have to do a heart disease, okay. So I hope your task 6 is clear to you all. If not, then you can ask me any doubt in the chat box right now. Is the description clear? Is the task description is clear? Yes or no? Yes. Okay. So please complete and submit your task on time. And if you face any doubt, then you can ask me in the doubt